Okay, let's see an example. The first example, show that f of function from n to n given by f of x is equal to x plus 1 if x is odd and x minus 1 if x is even is both 1, 1 and onto. So here the function is from where to where? From n to n. I shall just draw a subset of it. I cannot draw the entire set of natural numbers. So I take 1, 2, 3, 4, 5 and 6. Here also I have 1, 2, 3, 4, 5 and 6. If I can map and see all elements here up till 6 is mapped to this, and for all elements from 1 to 6 here which has a pre-image, it is both 1, 1 and on. So here f is a function from this set to this set. Under the given function, f of x is from n to n. Okay. When n is odd, that is when 1, x value is 1, 1 is odd, 1 plus 1, that is 1 is mapped to where? 1 plus 1. 1 is mapped to 2. 2 is even. So when it is even, it is 2 minus 1. Right? When 2 is even, when x is even, x belongs to this part, right? From to the domain of the function. 2 minus 1, it is 1. Okay. Now take 3. 3 is odd. So when 3 is odd, function's value is 3 plus 1. 3 plus 1 is 4. Right? When you take the next element 4, it is even. When it is even, x minus 1, that is 4 minus 1. 4 minus 1, 3. Okay. Now take 5. 5 is odd. 5 plus 1, 6. Right? Now 6 is mapped to where? 6 minus 1, 5. Right? So for every element that belongs to the domain of the function, do we have a unique image in the codomain of the function? Yes. So this function is 1, 1. For every element here in this codomain of the function, can you find a pre-image? This needn't be unique. Still you can find a pre-image. Yes. So it is onto. Now this is an arrow diagram to represent 1, 1 onto. But we are not proving 1, 1 onto by this method, but we need to prove it using algebraic method. So to prove it is 1, 1. To prove it is 1, 1. Since the function has two different values for x as odd and x as even, when x is odd. Okay, when x is odd, I am trying to say that the function is 1, 1. So let x1 comma x2 belongs to the domain of the function such that f of x1 equals f of x2. Right? Isn't this the way I prove it? I take two elements that belong to the domain of the function such that f of x1 equals f of x2. Now, to prove that it is 1, 1, what must I prove? x1 equals x2. Okay. So when it is odd, what is the function's value? x1 plus 1 is equal to x2 plus 1. Now, 1 and 1 cancels, which implies x1 equals x2. Therefore, f is 1, 1. I can notate in this manner also, 1, 1. Okay. Now, when x is even, let x1 comma x2 belongs to the domain of the function such that f of x1 equals f of x2. This implies what? When it is even, what is the function's value? x1 minus 1 is equal to x2 minus 1. Right? So this is equal to minus 1 cancels. This implies x1 is equal to x2. Further, I can say that f is 1, 1. Right? So in both the case, when x is odd as well as when x is even, the function is 1, 1. The function is 1, 1. Now in order to prove that it is onto, 1, 1 is also called as what, children? Injective function. 1, 1 or injective. Okay, onto, or it is called surjective function. So I take y is equal to x plus 1 implies x is equal to what? Y minus 1. For corresponding to every y, will I get a unique x? Yes or no? Yes. For any value of y taken, I get a unique x. So, therefore f is on 2. When you take it as, when you take f as odd, I have got it as on 2. When f is, or this function is even, when f is even, I have y is equal to x minus 1 or y plus 1 is equal to x. For every value of y, is this x unique? For every value of y, is this x unique? Yes. Therefore, f is what? On 2. This is how I show that f is 1, 1 and on 2. And when f is both 1, 1 and on 2, I conclude that this function is both 1, 1 and on 2. It is not given in the question. We call this function as a bijective function. So, how do we prove that it is 1, 1? By taking two values x1 and x2 belong to the domain of the function such that f of x1 equals f of x2. Right? On solving these values or these function, I must get x1 equal to x2, which implies that the function is a 1, 1 function. I hope it is clear. Okay. Now let's see more problems. Say the next problem. Let f be a function from r star to r star defined by f of x is equal to 1 by x. The function is defined as f of x equals 1 by x. Given r star is the set of non-zero real numbers. R star is the set of non-zero real numbers. Is f 1, 1 and on 2. Okay. You need to check whether f is 1, 1 and on 2 defined in the set r star to r star, where r star is the set of non-zero real numbers. Okay. Then we have a second part of the question. Let that be put on hold for the time being. So let us check whether it is 1, 1 and on 2 for the given condition given. Given f is a function from where to where? R star to R star. Okay. So now this R star is the domain of the function and this is the codomain of the function. Codomain of the function. Okay. Fine. Now given f of x is equal to 1 by x. How do you check for 1, 1? I take what? Let x1 comma x2 belongs to the domain of the function such that f of x1 equals f of x2. What does that mean? 1 by x1 equals 1 by x2. Can I write this implies x1 equals x2? Yes or no? Yes. Just take this up and just take this up. Okay, x1 equals x2. Therefore, f is what? 1, 1. Therefore, f is 1, 1. Now checking for on 2. I hope it is clear. Okay. Now checking for on 2. I have y is equal to what? 1 by x. What is y meaning? F of x. Y is the element in the codomain. Codomain means what? When f is a function that acts on the element x in the domain of the function, we get f of x. So f of x comes where? In the codomain of the function, that is the y element. So y is equal to 1 by x. This implies x is equal to 1 by y. What does this meaning? What is the meaning of this? This implies for every y which belongs to the codomain of the function. Okay? For every y that belongs to the codomain of the function, there exists what? An image, a pre-image. A pre-image in the domain of the function. Isn't it? For every y that belongs to the codomain of the function, there exists a pre-image in the domain of the function. That means what? Here the codomain of the function is equal to the range of the function. Can I come to the conclusion that the codomain of the function is same as the range of the function? Codomain means what? Every element that belongs to the second set. Second set is the codomain. For every element that belongs to the codomain, there exists a pre-image in the domain of the function. So I can say that every element is having the pre-image means what? The codomain is same as the range of the function, right? So if I can say this, the codomain of the function is equal to the range of the function, therefore f is onto. F is onto. Now coming to the second part of this question. F is a function now defined from n to r star, right? What is n? The set of natural numbers. So domain of the function is now replaced with n and the codomain that is remaining the same. That is what I have written here, r star, where r star is the set of non-zero real numbers. Okay, now let's see what happens to the range of the function here. For every value that belongs to n is a set of natural numbers starts with 1. So, what will be the image of 1 in r star? That will be 1 by 1, which is equal to 1. So, the range starts with 1, then corresponding to 2 in the set of natural numbers. The image of 2 in r star is 1 by 2. Then for 3 it is 1 by 3. For 4 it is 1 by 4 and so on. Right? That is, for any element that you choose from the set of natural numbers, you can find a image in r star. Now, that implies what? This function is a 1-1 function, because for every element that belongs to the set of natural numbers, you can find a unique image. Okay. Here, I say that this function now is a 1-1 function. Checking on for onto, that is, for every element that belongs to r star, there must be a pre-image in n. Now see, we have already written the range of the function and you have these as the values inside the range of the function. Now, this is this same as r star? Can I say that the entire set of the range of the function is the same as r star? No. Because in r star you have 2, 3, 4, etc. And even more numbers are there, which doesn't have a pre-image in the set of natural numbers, which doesn't have a pre-image. Only elements that belongs to the range is these, right? So I can say that this is the range of the function which is not equal to the codomain, that is r star. This is not equal to r star. So only if the range is equal to the codomain of the function. I repeat, when a function has its range as its codomain, when these both are same, I can say that the function is onto. But here, this is not equal to r star. So, can I say that this function is an onto function? No. Because still there are elements in r star which doesn't have a pre-image in n. So here I conclude my discussion by saying that the range of the function is not same as the codomain of the function and hence it is not onto, but still it is 1-1. In the second part of this question it is 1-1 but not onto. Okay. So that's it with this question. Now we move on to the next question. Check injectivity and surjectivity. What does that mean? To check for 1-1 and onto. For f, a function defined from r to r, defined as f of x to be equal to x square. Okay. So to check for 1-1, to check for the function 1-1, I consider let x1 comma x2 belongs to the domain of the function such that f of x1 equals f of x2. This is how we start to check for 1-1. Now here f of x1 equals f of x2 implies what? x1 square is equal to x2 square, right? Which implies x1 square minus x2 square is equal to 0. This implies x1 minus x2 into x1 plus x2 is equal to 0. Now from this I have x1 is equal to x2 and from this I have x1 is equal to minus x2. Right? Or I can say x1 is equal to plus or minus x2, which doesn't implies what? x1 is equal to x2. So what can I say? treated f of x1 is equal to f of x2, I found x1 is not equal to x2, which implies f is not 1, 1. F is not 1, 1. Now let's check for the function to be onto. Now, consider the value of y is equal to negative 5. Where does this y value belongs to? Y belongs to the codomain of the function, right? Y is equal to negative 5. That is, I can write f of x is equal to negative 5 because y is an element that belongs to the codomain of the function. Y is equal to f of x, so f of x is equal to negative 5. What is f of x here? X square. That implies x square is equal to negative 5. So, what is x? X is equal to plus or minus root of negative 5. Now, does this value be there in this R? For a value of y is equal to negative 5, definitely you will have negative 5 in the codomain of the function. But when I take this negative 5 and equate it for the given function x square and I am substituting it into this equation, and when I am solving for the value of x, I see that x is plus or minus root of negative 5. Does this belong to the set R? This R is where? The set of real numbers, which is the domain of the function. Does this expression belongs to the domain of the function set of real numbers? No. That means this doesn't belong to set of real numbers. That means this function is not an onto function. So here we see that when the function defined is from set R to set R and defined as f of x is equal to x square, it clearly states that the function is neither 1, 1 nor onto. I can conclude, therefore, f is not onto. I hope this is clear. Just go through this children.